Okay, so welcome back. The course is ELC3. Essentially, it's motors and generators, DC-wise and AC-wise. Okay, it deals with the conversion of mechanical energy into electrical energy, and then utilizing that electrical energy to convert back to mechanical energy. Okay, so basically, when you're going from mechanical to electrical, you're essentially creating a generator or an alternator if it's AC. And when you're going from the electricity to the motor, then you're basically talking using electricity and magnetism together. Okay. So basically, it's a back and forth type of thing. It's you go from a mechanical to electrical, electrical to back to mechanical, and it all involves a motion of some kind. And it deals with electricity, and it deals with magnetic induction. Okay, you need motion, you need electricity, you need magnetic induction. Okay, so the relationship between electricity and magnetism is the first thing that we'll probably look into. Okay, basically it's again a movement of the charge. Okay, if it's a translational movement, then we get electricity. If it's the charge is rotational, it is the movement is rotational, then we also get a magnetic parameter. Okay, so we will need to understand that electricity is translational, and when we have electrical that's rotational in effect, we will get magnetism. All right. So we need a basic knowledge of electrical and magnetics. The other thing that we also need to know is when we get to magnetics, that we're talking about energy transfers, okay? So energy can be normally is translated into one form to another, but there are losses involved, okay? And these losses we will understand in this course. We will pick them apart and understand how we can minimize those. To minimize those requires a little knowledge of the materials that are used, okay? Mainly we're talking about metallurgy. So we will get into some metallurgy. In fact, in today's lesson, I have a special document that you can read over that gives the material parameters to understand how you can make a good material, good magnetic material that will work well in motor and generators so that you minimize the amount of energy losses. All right. So we will start today then understanding first how where does the magnetism come from, and how the materials, what materials can be used for creating motors and generators. If you have any questions, call me up or email me something when you don't quite understand or see something, but all of this is fairly important, and it's one logical step after another. So we start off with generation on the DC side, okay, and next week we will get generation on the AC side and then motors, but this week we'll do DC generators and DC motors. It's important to understand that the magnetic induction for DC currents is very different than the magnetic induction that you get for AC currents. Okay, the AC currents have a reaction. DC only has a reaction at startup or end, or at the end of a cycle. Okay, it's not continuous. Whereas in AC circuit, you have continuous reaction, whether it's up or down. Okay, so we will get into that, and let's get on with it.